determine the value of D. Determine the value of D such that 15 congruent to 3 mod D. 15 congruent to 3 mod D. What is the meaning? 15 minus 3 is equal to D into some integer. D into some integer. So 15 congruent to 3 mod n means 15 minus 3 is equal to k into D, where k is some integer. So 12, 15 minus 3 equal to 12, you know. So 12 is equal to k into D. Gives D divides 12. What is given? That D divides 12. So what are the values? So the divisor of 12 are 1, 2, 3, 4, 6 and 12. Okay. But D should be larger than 3, and so possible values for D are 4, 6 and 12. Why should we take larger than 3? Why should we take larger than 3 means the remainder should be greater than the remainder should be less than the divisor. Okay, the remainder should be less than the divisor. That is the concept. So now we are going to find the divisor. You know, the remainder is 3 means the divisor must be larger than the remainder. So 3 larger than 3 are 4, 6 and 12. 4, 6 and 12. I hope you understand this. Listen. 15 congruent to 3 mod D. We are going to find the divisor. So if it is in the form of congruent modulo means we can write 15 minus 3 is equal to k into D. This k some integer. K is some integer. We do not know about it. When we divide, actually when we subtract 3 from 15, we get 12, which is equal to KD. Okay, so K which is equal to 12 by D. 12 by D. So the D should be the divisor of 12. D should be divisor of 12. The divisor of 12 are 1, 2, 3, 4, 6 and 12. The divisor of 12 are 1, 2, 3, 4, 6 and 12. Okay. But we should not take these 3. Why? The reason is we know that remainder 0 less than or equal to or less than B. Okay. 0 less than or equal to or less than B. Remainder is 3. Remainder is 3. Okay. So remainder should be less than B, you know. Remainder should be less than B. So the divisor must be 4, 6 and 12. 4, 6 and 12. This is the answer. Okay. I hope you understand why should not take 1, 2 and 3 are the divisor means the divisor should be greater than the remainder. Remainder is 3. So the larger than 3 are 4, 6 and 12. Example 2.13. Find the least positive value of x such that find the least positive value, okay, of x. 67 plus x congruent to 1 mod 4. 67 plus x congruent to 1 mod 4. 67 plus x congruent to 1 mod 4. Okay. So it can be written as 67 plus x minus 1, which is equal to 4 into k some integer. 4 into k some integer. 67 minus 1 gives 66 plus x, which is equal to 4k. Okay. So k is equal to 66 plus x divided by 4. 66 plus x divided by 4. If you assign the value of x After getting the result, it should be divisible by 4. Okay, so x, if you take x is equal to 1, if you take x is equal to 1, what do we get? 66 plus 1 is 67 divided by 4. It will not be divisible by 4. Okay, 60, if x is equal to 1, what do we get? 66 plus 1 is 67 by 4. Okay, so does not divisible. Okay, so if you assign x is equal to 2, x is equal to 2, so 66 plus 2 means 68 by 4. Can divide or not? 1 time 4, remaining 2, 7 times. Yes, exactly divide. Therefore the value of x is equal to 2. The value of x is equal to 2. Example number 2.14. Solve 8x congruent to 1 mod 11. Solve 8x congruent to 1 mod 11. 8x congruent to 1 mod 11 can be written as 8x minus 1 is equal to 11k for some integer k. Okay, so x is equal to, what do we get? 11k, the minus 1 becomes plus 1. So 11k plus 1 by 8. If you assign the value of k, it must be divisible by 8. If you assign the value of k, after simplifying, it must be divisible by 8. So what are the values? When we put k is equal to 5, when we put k is equal to 5, 11 into 5 is 55, 55 plus 1 is 56, 56 by 8 is equal to 7. It can be divisible by 8 exactly. After that 13, k equal to 13. If you assign k is equal to 13 means it is also divisible by 8. Like 21, 29. Then 11k plus 1 is divisible by 8. Therefore the solution are 7, 18, 29, 40 and so on. These are the possible values. Okay. Next, example 2.15. Compute x such that 10 power 4 congruent to x mod 19. 10 power 4 congruent to x mod 19. So 10 square is equal to 100. You know that. 10 square is equal to 100. 100 congruent to 5 mod 19. 100 congruent to 5 mod 19. So next 10 power 4 can be written as 10 square the whole square, you know. 10 power 4 can be written as 10 square the whole square. Congruent to 5 square, Power's law. Okay, if we take square on both sides, so here 10 square the whole square is equal to 5 square congruent to 5 square mod 19. So 10 power 4 congruent to 25 mod 19. So 10 power 4 congruent to 6 mod 19. How it possible? The 25 mod 19. 25 mod 19 means how many times? Actually 25 congruent to 6. 25 congruent to 6 mod 19. How many 19s are there in 25 means one time. Okay, it leaves a remainder 6. It leaves a remainder 6. So the 25 can be written as 25 congruent to 6 mod 19. So instead of this 25 mod 19, we have written 6 mod 19. Therefore x is equal to 6. X is equal to 6. I hope you understand this. Example 2.16. Find the number of integer solution of 3x congruent to 1. Find the number of integer solution. They asked clearly integer solution of 3x congruent to 1 mod 15. Solution 3x congruent to 1 mod 15 can be written as 3x, the plus 1 becomes minus 1, which is equal to 15k, where k is some integers. So 3x is equal to 15k, the minus 1 becomes plus 1. So 3x is equal to 15k plus 1. So x is equal to 15k plus 1 by 3. So x is equal to the 15k plus 1 by 3 can be rewritten as in the form of 5k plus 1 by 3. 5k plus 1 by 3. Since 5k is an integer. But 5k plus 1 by 3 cannot be an integer. Okay, listen. Here 5k is an integer. If you assign the value of k equal to 1, 5, minus 1 means minus 5. It is an integer. But here what do we get means x is equal to 5k plus 1 by 3. 5k plus 1 by 3. It should be a rational number. So 5k plus 1 by 3 cannot be an integer. So there is no integer solution. So the question has no integer solution, but it has rational number solution. Exercise number 2.3, question number 1, first subdivision. The question is 71 congruent to x mod 8. The question is 71 congruent to x mod 8. If it is in the form of congruent modulo, it can be written as in the form of 71, the plus x becomes minus x, which is equal to divisor into k, where k is some integer. Now we are going to find the value of x. So if you take this x right hand side, it becomes plus. So 71 minus 8k, which is equal to x. 71 minus 8k, which is equal to x, or 71 minus x divided by 8, which is equal to k. It can be written 71 minus 8k, which is equal to x, or 71 minus x divided by 8, which is equal to k. Better we can take this equation to find the value of x. Now we are going to assigning the value of x. After assigning the value of x, it should be divisible by 8. Okay. So 71 minus x. So if you assign the value of x is equal to 1 means what do we get? 71 minus 1 gives 70. 70 by 8. It will not be divisible by 8. And the before value is 8 table means 64. 64 can divide by 8, you know. So how can we get this 64? If you subtract 71 minus 7, we can get 64. 71 minus 7, which is equal to 64. So x, which is equal to 7. Okay. So 71 minus 7 divided by 8, which is equal to 71 minus 7 is equal to 64 by 8. 1 times 8 times. Okay. So after assigning the value of x is equal to 7, it will be divisible by 8. Therefore, the required value of x is equal to 7. Okay, this will be the least positive value. Okay. Third subdivision. 89 congruent to x plus 3 mod 4. 89 congruent to x plus 3 mod 4. Solution. This can be written as 89 minus of x plus 3, which is equal to 4 into k, where k is some integer. So 89 minus x minus 3, minus x minus 3, which is equal to 4k. Okay. So 89 minus 3 is equal to 86 minus x, which is equal to 4k. So k is equal to 86 minus x divided by 4. 86 minus x divided by 4. Now we are going to assigning the value of x. After assigning the value of x, it should be divisible by 4. It should be divisible by 4. If you assign the value of x is equal to 2. X is equal to 2. 86 minus 2 is equal to 84. 84 can be divisible by 4. 84 can be divisible by 4. Therefore, the least positive value of x is equal to 2. First question, fourth subdivision. 96 congruent to x by 7 mod 5. Okay. As usual, first 96 minus x by 7. The plus x by 7 becomes minus x by 7 is equal to 5k, where k is some integer. So 7, okay, if you take 7, LCM is 7, means here we got 96 into 7. 96 into 7. 7 6 are 42, remaining 4. 7 9s are 63, 67. 672 minus x, which is equal to 5k. Which is equal to 5k. So k is equal to 672 minus x divided by 35. 672 minus x divided by 35. If you assign the value of x, the resultant value should be divisible by 35. Should be divisible by 35. So what is the value? If you assign x is equal to 7, so what do we get? 672 minus 7. 12 minus 7, 5, 6, 665. 665 divided by 35. It will be exactly divide. Okay. So the least value of x is 7. The least value of x is 7. You can ask me, how can we find the value of x? Exercise number 2.3, question number 2. The question is x congruent to 13 mod 17 and 7x minus 3 congruent to what when mod 17. Okay, so we are going to find this unknown. So first, from this one, x minus 13, which is equal to 17k, it can be rewritten as in the form of x minus 13, which is equal to 17k. Okay, so value of x, actually k is equal to x minus 13 by 17. K is equal to x minus 13 by 17. If you assign the value of x, the resultant value should be divisible by 17. Okay, so less than 13 means it will not be divisible by 13. The next value must be 30. 30 minus 13 divided by 17. So 30 minus 13 gives 17 by 17. So 1. Okay, therefore value of x, which is equal to 30. Value of x is equal to 30. From this, let the unknown be p. Let the unknown p be. So 7x minus 3 congruent to p mod 17. 7x, x value 30. 7 into 30 minus 3 minus p, which is equal to 17k, where k is some integer. 7 into 30, what is the value? 210 minus 3 minus p, which is equal to 17k. 210 minus 3 leaves a remainder 207 minus p, which is equal to 17k. This value will be multiple of 17. Multiple of 17. So what is the value of p? Okay. So this 207 can be written as congruent to p mod 17. Can we write 207 congruent to p mod 17? Okay. So the value of p, when we divide 207 by 17, what it leaves? So 207 divided by 17. So one time here 17, remaining 3, 17. So here 2 times 34, it leaves a remainder 3. Okay. So 207 congruent to the remainder is 3 when divided by 17. So the value of p, is equal to 3. Exercise number 2.3, question number 3. Solve 5x congruent to 4 mod 6. It can be rewritten as in the form of 5x minus 4, which is equal to 6k, where k is some integer. Okay. So now 5x minus 4 divided by 6, which is equal to k. If you take like this, after assigning the value of x, it should be divisible by 6. Suppose that x is equal to 1. What do we get? 5 into 1, 5. 5 minus 4, 1. 1 by 6. 1 cannot be divided by 6. So we cannot assign the value of x. Next, if x is equal to 2. So x is equal to 2 means 5 into 2 minus 4. 5 into 2 minus 4 divided by 6. 5 into 2, 10. 10 minus 4, 6. 6 by 6, 1. So exactly divide. So value of x is equal to 2. Then x is equal to another one value. If x is equal to 8. X is equal to 8 means 5 into 8, 40. 40 minus 4, 36. Thus 36 can be divided by 6. Or if you take, this will be the equation, means after assigning the value of x, it will be the multiple of 6. It should be the multiple of 6. So 5 into 2, 10. 10 minus 4, 6. 6 is multiple of 6. The next 8. 8 means 5 into 8, 40. 40 minus 4, 36. 36 is multiple of 6. Okay. Then 14 and so on. Okay. So x, which is equal to 2, 8, 14, and so on. Okay. This is the answer. Question number 4. Solve 3x minus 2 congruent to 0 mod 11. Actually, when this will be divided by 11, it leaves a remainder 0. Okay. So solution: 3x minus 2, this 0 becomes minus 0. Need not to write that, which is equal to 11 into k, where k some integer. So value of x, are, what are they? So after assigning the value of x, it will be the multiple of 11. So if you assign value of x is equal to 1, so what do we get? If you assign value of 1 means 3 into 1, 3, 3 minus 2, 1. 1 will not be the multiple of 11. 2, 3, 4 like that. Okay. If you assign value of 8, so 3 into 8 24. 3 into 8 24. 24 minus 2. X is equal to 8. X is equal to 8 means 3 into 8 minus 2. 3 into 8 24 minus 2. Multiple of 11. Multiple of 11. So one of the value is equal to 8. Then next, x is equal to 19. X is equal to 19. 3 into 19 minus 2. 3 into 19. Actually 57. 57 minus 2, 55. It is multiple of 11. Okay. So the value of x, which is equal to 8, 19, and the next one 30, and so on. This is one of the way to find the value of x. Another one, from 3x minus 2 equal to 11k. 3x minus 2 which is equal to 11k. Okay. So now 3x which is equal to 11k plus 2. Now minus 2 becomes plus 2. 3x is equal to 11k plus 2. So x is equal to 11k plus 2 divided by 3. Okay. So the value of k, after assigning the value of k, the resultant value should be divisible by 3. That will be the value of x. Okay. So if here k equal to 2, if you assign k equal to 2, so 2 into 11, 22. 22 plus 2, 24. 24 by 3. Exactly divisible. So the value of x, which is equal to 8. Then next one, x is equal to, if you assign the value of k equal to 5. 5 means 11 into 5, 55. 11 into 5 plus 2, it should be divisible by 3, 11 into 5, 55. 55 plus 2, 57. 57 by 3 is equal to 19. Okay. So x, next value, k value, what shall we assign? If you assign k is equal to 8, 11 into 8, 88. 88 plus 2, 90. That 90 can be divided by 3. That value of x is equal to 30. Therefore x is equal to 8, 19, 30, and so on. So the value of x is equal to 8, 19, and 30. Either you can follow this one or this one. Okay. Both are very easy only.